Sonic, the heart of your system.
Hi and welcome to a new video here on my channel. That's a video I've been looking forward to for a very long time because that's a topic I really love and I used to do for a very long time, especially when I was really active in my extreme overclocking career, because we are going to talk about e-power or zombie cards. So for example, this one, it's a 8800 GTS G80, so it's from Nvidia from around 2010, maybe 2011, can't really remember, something in this direction, maybe 2009. It's a G80 GPU, so 8800 GTS. Back in the days, voltage supply of this card was okay for stock, obviously, but for overclocking, especially for serious overclocking, it's not enough because you have OVP, over voltage protection, which means that if you're supplying too much voltage to the card over a mod, it would shut down. Same goes for OCP, over current protection, so if too much current is flowing to your GPU, it would again shut down. Using e-power solutions like this one, it's an EVGA e-power board, we can just bypass any kind of protections because they simply don't exist on the e-power boards. That's why we used to do those e-power solutions. I have different modified cards here on my table, which we will take a look at later. Also different e-power modules, which we will also take a look at later. There are multiple reasons why you would do an external power supply modification like the ones you can see on my table. For example, this one, it's for a very special HW bot overclocking challenge. I think it was like 4 or 5 years ago. You can see this is PCI, so that was a card, a GPU for PCI, not for PCI Express. That's a big difference. And it didn't have an external voltage supply, so it didn't have like a 6-pin or an 8-pin voltage supply from the PSU, so it's very power limited. Even if we would just do a normal feedback volt modification, it would be really power limited. That's why I decided to go for an e-power solution on here. I will also explain what a feedback modification is. So looking at this, you can see it's the first generation EVGA e-power module. We have 2x6 pin for GPU, we have 1x6 pin for memory. I will just show you how this works in theory. So there is an 5-pin connector up here where we can supply the EV bot. If we just connect, 6-pin power supply and switch on this power supply here, 24-pin is shorted obviously. You can see this one turns on and then we can actually set the voltage that's being supplied from the e-power module to the card. So the big problem of those e-power solutions is they're kind of universal, and especially when we're talking about all the older hardware, it doesn't always work. So in this case, for example, we have GDDR3 on this card. GDDR3 is typically set with a starting voltage of like 1.8 volt. But the EVGA e-power module starts at about 1.5 volt, if I remember correctly. So if you just attach this and attach it to the memory as well, the memory supply voltage is too low. So you start with the memory supply voltage of 1.5 to the card, while the memory just needs like 1.8 to really work. So you cannot really boot into Windows. It would typically just crash during Windows loading because the voltage supply is too low. So it means every single time you're powering up your system, you would have to connect the EV bot and then set the voltage directly before you're loading Windows, which can really be a problem, especially when you're doing extreme overclocking. You have to be really quick because it just crashes so often. That's really why it's a pain in the ass to do that. That's the reason why you see those blue trim pots on here. So they're adjustable resistors. And basically what they're doing is a feedback modification. Feedback modification means that we have the GPU voltage controller here and we have the memory voltage controller on here. And basically the feedback loop is that the IC is just measuring the voltage that's being supplied to the GPU, and then it's feeding it back to the controller, and then the controller is adjusting the voltage accordingly, because you have a target voltage that can maybe be like 1 volt. And it's measuring if there is 1 volt, but if we're tricking the feedback loop and we're with this parallel resistor, we're like simulating that only 0.9 volt are supplied to the GPU, then the controller will regulate and then the result will be like 1.1 volts. So it's a very simple modification. It's a feedback loop modification. It works very well, especially on older cards. Nowadays it doesn't really work anymore. It depends on the controller of your GPU, if it works or not. Cannot really always say that about nowadays GPUs. Often it doesn't work anymore, but on the e-power module, it works really well. That's why we can, for example, adjust the memory voltage supply directly to 2 volt instead of 1.5, and then it will always work and it will always be directly at the right operating voltage, and the same goes for the GPU. That's why I did a feedback loop modification on the first generation e-power. Same kind of modification was done to this card. So again, first generation e-power, it's an 8800 GTS, it's a G80 100, it's an A3, so it's an 8800 GTS 640 megabyte, but it's A3 revision, so those were the best clocking GPUs of this generation, and I attached the module to just be the best in HWBot with this card, or try it at least. And again, it's the same here. We have feedback modifications for the e-power module to be able to make this card work or boot into Windows without adjusting anything with the e-power, with the EVBot. Then we have another card, which is GF 110 275 GPU, which means it's a GTX 570. You can see it's a second generation e-power from EVGA attached to this card, and in this case it's only applying vGPU. It's not applying memory voltage. The memory voltage is still stock, so those two phases on here, those are for memory supply, and only GPU voltage is done with the external module. That's actually a bit more tricky because you have to be more careful. There are some security things on the card that would prevent your card from powering on if you do a modification like this, and the GPU doesn't detect a proper voltage supply from the vGPU controller, then it would also prevent your memory voltage to start up, so it wouldn't work. That's why this kind of modification, where you use, for example, only vGPU from external source, but rely on like onboard components for VDIM then, or vMemory, then it's kind of a problem. It's a bit more tricky, but you will see later on the card which we will do for this video how this works. Then we can also talk about the different modules or e-power modules I have. So we already talked about the EVGA modules, so first and second generation. They're very similar. The first generation has lower power output than the second one, but the first generation also has 2 outputs. So we have vGPU and vMemory, while the second generation only has 4 GPU supplies. So I'm not really a fan of the second generation e-power from EVGA. This one is from Galax. It's also only a single output, so it's only for vGPU as well. It's very similar to the second generation EVGA. I didn't really use it that often. I used it for the first Titan generation in quad SLI. That's also the reason why you can see there's some residue from a glue on the heatsink, because originally there was a fan glued to it, attached to it, which I had to remove because we were using 4 of them for quad SLI, and in the sandwich there was just simply not enough space to have the fan in there, so I had to remove the fan. That's why there's still the residue of the glue on there. This power module worked okay. I didn't really have issues with it, but I was also not really a fan of it. It didn't really have, I mean, just a single output is most of the time not really that great. Then we're going over to the Gigabyte G-Power, which for some time was my favorite until I tested it. It's actually quite nice. You have 5x8 pins, so power supply is really not a problem. You can see there's a fan attached to it with a quite big heatsink to make sure that the VRM is properly cooled. And we have 3 voltage outputs. So we have GPU, we have memory, and we also have for PLL. So that's pretty much the ideal solution for any nowadays GPU, because they have 3 main power supplies, so it's at least NVIDIA cards, so it's mostly GPU, memory, and PLL. So this is really nice. It also comes with this, the G-PowerBot controller. It's very similar to the EVBot, so I mean it looks pretty similar. It's almost the same, so you can adjust the voltages on this card with the G-PowerBot controller. But the only problem with this I had was whenever I attached it to a card memory voltage, so let's say I had vGPU, I had vMemory, and I applied the card to it, memory clocks were always worse afterwards. I mean, there's more than just the voltage being applied to a card. I mean, there's also frequency and what kind of capacitors they're using and all this kind of stuff. And for some reason, whenever I applied the G-Power module to the memory clocks were much worse afterwards. So I was, in the end, not really a fan of the G-Power module. Going over to my favorite, it's very similar to the latest EVGA, like the 3rd generation e-power board from EVGA, which is actually up for sale. Tried to order one, but the EVGA shop didn't let me order it, so I still didn't order it up to now. Still want to do it, but didn't have time to do it. Anyway, the Asus Amp Power Card 2. So it's also the 2nd generation of the Asus card. I'm not really sure where I have the 1st generation. I have one somewhere, but I couldn't find it anymore. Anyway, so we have 8 phases for GPU supply, we have 2 phases for memory supply, we have 1 phase for PLL. What I really like about this, I mean, you have a lot of space on here to solder any kind of connections to it, also on the back, which makes it extremely convenient to use. But then the control is also really nice. I'm not that much a fan of having those external controllers, especially if you're using multiple cards, but this is really nice. So for example, you have just control over those 8 segment or 7 segments LEDs on here, so you can just adjust the voltage with those buttons, and you also have offset switches where you can directly start with like plus 0.1, 0.2, 0.3 volts, which is basically what we needed on the 1st generation e-power module, because we needed those kind of offsets to make the card boot. You can directly do that on here. It's just flip the switch and then it's already like plus 0.2 volt, which made it really convenient to use. And that's up to now my favorite e-power solution, and that's what we will also use today to modify this card. For today's e-power modification, we will use this GTX 1060, which you can see has a big problem over here. This is the memory voltage, this is GPU voltage and memory voltage. The MOSFET is broken, so it burned for some reason, not really sure why. The most important factor is that this is not shorted to ground, so this is fine. That's something we have to check before we do a kind of modification like this, if a component is burned. So we have 1 phase for the memory voltage, and then we have 5 phases for vgpu, and those are the 2 sources which we will replace in today's video with the e-power module. It's really important to check the resistance of memory and also GPU to ground before we do any kind of modifications, so we have reference points. Also, first double check resistance if you short the multimeter. In this case we have like 0.7 ohm, could be 0.8, sometimes it goes up to 0.9. Yeah. Now we have to check the memory voltage resistance to ground. So we just check it from the inductor over here. And if we check that, we have about 30 ohm. Typically you have something between 25 and 60 ohm for memories. So that's perfectly fine. In this case we know that even though the MOSFET is burned, it's not shorted to ground. If we would read like 0.9 ohm, in this case we would have to remove the MOSFET first before doing the modification. Also we have to check vgpu to ground. You can just pick any kind of ground spot and you can see it's 1.2, 1.3 ohm. Typically GPUs have a very low resistance to ground, so that's why I'm telling you to just double check your internal resistance of the multimeter first. You can see it's only 0.1, 0.2 ohm difference, so it's really small difference, but you have to check that before, because that's something we have to check during the modification all the time. If we're adding ground wires or if we're adding vGPU wires, and if we do some scratching to use some of those layers, then we always have to double check resistance. In the first step, we have to remove the inductors. So the original voltage supply comes from the PSU over the 8-pin connector, goes through the shunt resistor to the memory and also to the GPU supply. And it doesn't really matter what those voltage supplies are doing. If we just remove the inductors, we're cutting off the voltage supply to the memory and also the voltage supply to the GPU. So that's the first step, removing all the inductors. I know you all love and hate me for my soldering equipment, and for today's video we're using this thing. It's an ERSA 150 watt soldering iron, and you will probably think, what the fuck is this? Why is this so big? And yeah, we need this massive soldering iron because especially the inductors, they can take up so much heat. So if we're heating up the inductors with a very small or normal soldering iron, it will take forever, and I'm not really sure if you're able to remove them, especially later once you're connecting this over very thick wires or like even copper plates. Then you need a lot of heat, and 150 watt soldering iron is really what I would recommend for that. After removing the inductors, it's very important to double check resistance. Actually, we have to double check resistance after every single step we're doing. Like after every single wire, you should always double check resistance. Memory resistance is now like 35 ohm, something in this direction, 39. That's totally fine. Everything is fine between like 25 and 60 ohm. That's the typical direction. As long as it's not shorted to ground, everything is good. Double checking vgpu to ground as well. It's like 1.1 ohm. That's also perfectly fine. So in theory, the only thing we have to do is attach the external power supply now. But we also have to think about the GPU controller, the vGPU controller, because this one is actually connected to the GPU, and if there's anything false, if there's anything wrong with the vGPU supply, then the controller will prevent that the GPU is powering on. So there is the power goods signal, which is the third pin from the bottom, from here, but it's very hard to see. The solution would be to cut this trace of the third pin to make sure the power goods signal is cut. In this case, it would power on the GPU. But since I cannot really see it, and in some cases you don't really have access to the data sheets of those controllers, so the more elegant, or actually it's not elegant, but it's a solution that always works, is to just remove the vGPU controller entirely. We will unsolder the vGPU controller with a hot air gun, but to protect the surrounding components we will use a Kapton tape, which is a very temperature resistant tape. Simply glue it around the vGPU controller, which will protect like those capacitors and all the other SMD components. GPU controller is removed. It rarely worked as good as this time. You can see it's really clean the way it got removed, and we will now add a little bit of flux to the contacts and then go with the soldering iron across the contacts to make sure that there are no shorts. The goal is to attach the power card in this kind of direction to here, which is the GPU voltage supply, and to the area on top here, which is the memory voltage supply. We have vGPU here, we have ground here, and we have the memory here. So we will attach it some way like this. We also have to insulate this area with some tape later to make sure that the back of the card is not shorting anything on here. But for now we have to increase the surface area of the vGPU connection. That's mainly because we will have a voltage drop from the card to the GPU, and the more surface and more contact area we have, the less the voltage drop will be. So the goal is to find spots where we can increase surface area. It's actually very simple to do that. We know that this spot here is connected to the GPU. So all we have to do is just go in areas where we think it could be connected to the GPU and just simply scratch a little bit with the tip of the multimeter until it makes contact, and then we see 0.9 ohm, so it's directly connected. We do the same with the memory. So the memory plane is this one here. So we have a power area for the memory. This is actually fine surface-wise, so we'll just increase this a little bit with a Dremel. We also need ground, so we know this is GPU, and then we're searching for ground, so we have a massive area on here. I'm not really sure if you can see that in the camera, but sometimes you can see some layers on the PCB. Once you see a big layer, you simply scratch on it. You can see 1.3, maybe 1.2, 1.1 ohm. So this area here is also ground. So we will use this top area here and some of those spots for ground. We will increase this surface area for GPU, and we will increase this surface area here for the memory. This is the most crucial point of doing this kind of modification. We will increase the surface area, we will remove all those soldering masks. The problem is if we grind too deep, then we can kind of short or connect some of those layers in between. So we have to be really, really careful. If we go too deep, then it's a problem, then we can break the card. A final check before we start attaching the power board, starting with the GPU voltage supply, 1.6 ohm, that's perfect, so no short here. Should be like 30, 35, yep, perfect, and the additional ground connection is about 1 ohm, so that's perfectly fine, it's perfectly in line. Now we can start attaching the power board. I'm using some very thick copper wire with 2 millimeters diameter, and the positive and also negative part is that it's insulated on the outside with some kind of, I don't know, paint or layer that looks like shiny golden. The thing is, if I'm using this, for example, on here, I always have to like grind off and remove this layer, the insulation layer. But it's also very helpful. For example, now on this point where I'm soldering it to the memory area, I can make sure that if I put this in between those ground wires, it's not shorting anything. I think I'm pretty much done with the soldering work. I could add a little bit more ground wires or additional vgpu wires, but for now I think this is fine to just check if everything is working. One final check for the resistance, checking from ground to ground. If we shorted anything here or have something weird, but this is fine, 0.9. If we check to vgpu, we have 1.1, so that's also totally fine. Checking to memory voltage. Yeah, still around 30, 35 ohm. Everything looks to be fine. So final check is mount this thing into a system and see if everything is up and running. I set up the card for testing. It's mounted with a riser cable with this C390 platform. The power board is connected to the PSU and also the card is connected to the PSU. I have an old LN2 chipset cooler which I will just use quickly to put it onto the GPU to dissipate the heat, to make sure nothing is burning if we switch it on. What we always have to keep in mind, especially once we are powering this from a second PSU, which is typically what we're doing, powering the system from one PSU, the card from a second PSU. If we power this on with an additional PSU, the GPU will always be hot, no matter if the system is running or not. So that's why we have this additional cooler. Everything is up and running. We can see we're in BIOS, so we have display signal, the card is fine, the container here is getting a little bit warm, so yeah, there's some heat coming to the container. Everything is fine. It's 1.2 volt applied to the GPU right now. I'm not sure what the memory voltage is. It should be 1.5 volt. I have to double check that, but that's what we will do in an additional video when we will mount this to a proper LN2 container and test the card for, I don't know, maybe dry ice, liquid nitrogen, or whatever we have available. Maybe start with water cooling first and just see what we can get out of the card if we have a power supply like this. I hope you enjoyed this video, learned something and how to use those external power supplies. If you have questions, put it down in the comments. If you have some kind of wishes, what kind of card you would like to see modded in the future, also let me know. See you soon.